Okay, hello everyone, it's me, Mr. Dінмұхамед, and today I'll explain you one interesting topic. Before that, I want to tell you one interesting story. And when I was 17, I studied in GIC as mathematics teacher, and I didn't know about geometry at all. And once in practice, I was given 3 topics on geometry, and I thought it would be too much for me. But my teacher, Bayan teacher, explained me all the topics to me, and it turns out there are no topics that are easy than geometry. Okay, today is our topic about regular polygons and their properties and symmetries. After this lesson, you will be able to know and apply the properties of inscribed and circumscribed quadrilaterals. Okay, before I want to give you some definition to these words. Circumscribed quadrilateral and cyclic quadrilateral. Circumscribed quadrilateral is sometimes just tangent quadrilateral. It's a convex quadrilateral whose sides all can be tangent to a single circle within the quadrilateral. And a cyclic quadrilateral is a 4-sided polygon whose verticals are inscribed on a circle. And also, you can see parallelogram, and we cannot draw the circle around into the rectangle like in the case with triangle. When all angles of a triangle tangent with a circle, for instance, our parallelogram can't contain no circles inside and can't reach all 4 corners at edge. And 5 fingers are not the same. Like parallelogram, humanity has the various types of souls and abilities. So to reach our circle's edge, we have to improve our weak abilities like parallelogram and as corners and be already full. And as I said, the cyclic quadrilaterals is a 4-sided and polygon whose verticals are inscribed on a circle. Before we consider the properties of cyclic quadrilaterals, we resolve an important term about inscribed angles and central angles. An angle at the center of a circle with end points on its circumference. As I explained you in the last topic, an angle theta inscribed in a circle is a half of the central angle. And it's a 2 theta that subtends the same arc on the circle. In other words, the angle at the circumference is half the angle at the center. And our first theorem is the measure of the opposite angles in a cyclic quadrilateral are supplementary. That is, they add to 180 degrees. Okay, we will prove our theorem, and let us now consider the cyclic quadrilateral ABCD. We can join 2 verticals A and C to the center O to create 2 radii, AO and OC. We can label the angle measures created at the center of the circle as x degree and y degree. And we know that our inscribed angle theorem, and it's our B angle equals to 1 over 2 x degree, and also our angle D equals to 1 over 2 y degree. Then we can write it like this: angle B plus angle D, and 1 over 2 x degree plus 1 over 2 y degree. And our sum of angle equals to 1 over 2 x degree plus y degree. And we know that x degree equals to y degree equals to 360 degree. Then our x degree plus y degree equals to 360 degree. And we will divide it by 2, and our sum of angles, these angles, B and D, equals to 180 degree. We prove it. It's our first example. Determine angle C if angle A equals to 78 degree. As we can see, it's a cyclic quadrilateral, and then we can use our theorem, and angle C plus angle A equals to 180 degrees. And our angle A equals to 78 degrees, then angle C plus 78 degree equals to 180 degrees. And our angle C equals to 102 degrees. And our second example, given that angle A equals to y degree and angle B equals to 4x minus 3 degree and angle C equals to 5x degree. We can first of all we have to draw at our given measures like that. Our angle A and angle A equals to y, and our angle B equals to 4x minus 3, and angle C equals to 5x degree, and 5x degree. And we can use our first theorem. How can we use this theorem? First of all, we can find our x, and 115 plus 4x minus 3 equals to 180 degrees. And then our 120 plus 4x equals to 180 degrees. Then our 4x equals to 68 degrees. Our x equals to 17 degrees. After that, we know that our x equals to 70 degrees. Then we can find these angles, and angle A plus angle C equals to y degree plus 5x degree. And then we can use our x, and angle A plus angle C equals to y degree plus 1 degree plus 5 multiply 17. And then our A plus C equals to 180 degree. And our y degree plus 85 degree. Then our y equals to 95 degree. That's all. Okay, our second theorem. If sums of these opposite sides are equal, then quadrilateral can be circumscribed about a circle. If quadrilateral can be circumscribed about a circle, then sums of its opposite sides are equal. We can use tangent lines properties. It's AP and AT are tangent to this circumference, and AP equals to AT, and also like this, BP equals to BQ, and QS equals to SR, and TD equals to RD. Then we can write it like this: AP plus BB and plus CR and plus RD equals to BQ plus QC plus AG plus TG. Then we will get it: AB plus CD equals to BC plus AD. It's our second theorem. And our third example, As we can see, IJ equals to 9 centimeters and LI equals to 11 centimeters and JK equals to 15 centimeters. And we have to find LK. And we know our term LK plus 9 equals to 11 plus 15. Then LK plus 9 equals to 26. Our LK equals to 17 centimeters. So first example, and given AB equals to x plus 7 and DC equals to 2x plus 1 and AD equals to 3x minus 1, BC equals to x plus 5, and we have to find AD, our AD length. And first of all, we have to find our x, and we use our second theorem. It's sum of these two lengths equals to sum of these two lengths, and we can write it like this: DC plus AB equals to AD plus CB. Then we can write it like this: 2x plus 1 plus x plus 7 is equals to 3x minus 2 plus x plus 5. Then 3x plus 8 equals to 4x plus 3. Then our x equals to 5. And we found our x, and we just put it here. And our AD equals to 3x minus 2. Then our AD equal to 15 minus 2. AD equals to 13. That's all. Okay guys, I think so this topic was clearly, and goodbye.